Hi guys, so in this video I'm going to go through a couple of examples of some problems that you could see on your quiz on Friday or Monday, depending on which day you have math class. So the first example that I'm going to show is if you're given a fraction, so for example 8 over 25, and you want to write that fraction as a decimal. What I want to think about is my denominator. So my denominator of 25 does not automatically tell me what this decimal is going to be. So I don't know where that 8 is going to go. So when I'm thinking about this example here, I think about 25. I know that 25, oh my gosh, can be scaled up to 100 by multiplying by 4. So I can do the same in my numerator. 8 times 4 is going to give me 32. Sorry, guys. Let me exit out and put it back on again. So if I think about 32 over 100, that is going to be a friendly fraction that I can then pretty easily change into a decimal because I have a friendly denominator of 100. So 32 hundredths is going to be 0.32. This is going to be a terminating decimal because if I do 32 divided by 100, I'm going to get a remainder of 0. So 8 over 25 was friendly to change into a fraction or into a decimal because my denominator of 25 was really easily able to change into 32 hundredths, which is a friendly denominator. But let's think about if we had something that wasn't so friendly and didn't scale up to 100. So say I had the example 8 over 40. So if I think about my denominator of 40, I can't scale up 40 to 100 because I'm going to be multiplying by a decimal. But if we think about 8 40ths, I know that I can simplify 8 40ths to 4 20ths. Then I have a friendly denominator of 20 that I can then scale up to 100 by multiplying by 5. 4 times 5 will give me 20. So 20 hundredths will be 0.20 or 0.2. I can write it either way. Something else I can do from 420 is I can say, well, 4 20ths is also equivalent to 2 tenths. So I can divide by 2. 2 tenths I can then write as a decimal. So kind of a couple of different options that we can use with 8 over 40. So even though 40 didn't go into 100 evenly, I could simplify it into two friendly fractions that then I can easily write as a decimal. Well, what if I can't simplify and get to something that's friendly? So for example, what if I had the fraction 14 over 15? And we wanted to write 14 fifteenths as a decimal. Well, 15 is not going to go up to 100. I can't simplify 14 fifteenths because 14 and 15 don't have anything in common. And I can't scale up 15 to 1,000. So the only choice I'm going to have here is to divide. So when I think about my division, I need to figure out which number is going to go inside and which number is going to go outside. Well, if I think about this here, and I think about my fraction bar as a division sign, this is going to be 14 divided by 5. When I think about 14 divided by, 15, the 14 is going to go inside. So 15 is going to go into 14 0 times. I have a remainder of 14. Since I don't have anything more to pull from, I'm going to add a decimal and a couple of zeros and move my decimal up to the top here so that I can keep dividing. So then I can pull down my 0. 15 is going to go into 140. That's when we come over here and we try some stuff. So I'm going to try 15 times, I'm going to try 9. So that would be 45. That'd be 135. Perfect. That one works. So I'm going to put my 9 here. 15 times 9 is 135. I subtract and get 5. I still have a remainder, so I pull down my 0. 15 goes into 50 3 times. 15 times 3 is 45. And I get a 5 again. So that means I bring down my 0. I'm going to continue to get a remainder of 5 and bring down that 0 over and over and over again. So that tells me that my 3 is repeating. So this is going to be a repeating decimal because my 3 is going to go on forever and ever. So that would be my answer there. Now I would use the same strategy. Here I'm using just fractions, but if I had a mixed number, so for example, if I had 6 and let's see, 15 over 50. And I wanted to write this as a decimal. Well, I could know that I'm going to have 6 in my ones place because I have 6 wholes. So then I can kind of ignore it and just think about 15/50ths. Well, 15/50ths is nice because that easily scales up to 30/100ths. So this would be 6.30 or 6.3. So when you have a mixed number, I just kind of write it in my decimal. I ignore it, and then I think about the fractional part, what that will be as a decimal. Okay, so that's a quick overview there. Now, what if I asked you to write a decimal as a fraction? So for example, if I gave you 0.16 repeating, and I said, what is that as a fraction? Since I have this repeating bar over my 16, I know that it's going to be really, really close to 0.16, but it's going to be different because 0.16 is terminating, so I'm going to have zeros repeating. Here, I'm going to have 16 repeating. So if we look in the thousands place, these are going to be different. So if we think about 0.16 repeating, I have a repeating bar over my 2 decimal places. So when we think about how we get rid of the repeating decimal part, I can set my x equal to my repeating part. Since I have 2 decimal places repeating, I'm going to multiply x by 100. So when I multiply x by 100, I'm going to move my decimal place 2 times to the right. When I do so, I'm now going to have a whole number of 16, and then these 16s are going to continue to repeat over and over and over again. So then to get rid of the repeating parts, I can subtract 100x minus x. So I line up the decimal place correctly, and all of these 16s are going to cancel out and make 0, 0, those are going to cancel out. 16 minus 0 is 16. Same here, the repeating part is going to cancel out, and I will be left with 16. And then I will do 100x minus x, which is 99x. So 99x equals 16. So then to get x by itself, I'm going to divide both sides by 99. X equals 16 over 99. Now, if we look at the connection between 16 over 99 and how many decimal places are repeating, I have 2 decimal places repeating. So that tells me that my denominator is going to be 99, 2 decimals repeating, which is different than if I say maybe had 3 decimal places repeating. So say I had 0.257 with the repeating bar here. I have 3 decimal places repeating, so my denominator will be 999, and then my numerator will be the part that's repeating. So we don't actually need to go through and do all of this work to prove each time, but we could. So this fraction will be here. Then I think, is it simplified? Well, 2 plus 5 plus 7 equals 14. 14 is not divisible by 3, so 3 won't go into here. I don't really know if they have anything in common. I'm going to kind of pause there, though. So that will be our fraction. Just keep in mind, with our repeating decimals, the denominator is going to be a little bit different. So you will see repeating decimals. You will also see fractions. So we're going to have to add and subtract fractions. Now we're going to see some that have common denominators and some that have uncommon denominators. So in lesson 5.2, we talked about only when they have a common denominator, which means they have the same denominator. So if we think about an example of 15 thirteenths plus 8 thirteenths, I notice that they have the same denominator, which means they have the same size pieces. So since they're both thirteenths, I can add the numerators. 15 plus 8 is going to give us 23, and I keep my denominator the same. So it's kind of like I have 15 pieces, each in equal size, and I have 8 pieces, each in equal size. So 15 plus 8 pieces is 23 total pieces. So then that means that I put my 23 pieces over 13. I can keep it like this, or I can write it as a mixed number, which would be 1 and 10/13. Either of those works there. Now I can also see examples where I have variables, either in my numerator or my denominator. So for example, 2x over 3 plus 8x over 3. So since these fractions have a common denominator, which means they have the same size pieces, I can add my numerators. So 2x plus 8x, keep my denominator the same, will be 10x over 3. I want to keep it like an improper fraction because if I change it to a mixed number, which would be 3 1/3, I can't do it like this where I have 3 with x over 3. The reason why is if I change this to an improper, 3 times 3 is 9. 9 plus x, I cannot combine those. So this mixed number would be this improper fraction, which is not equal to this improper fraction. So we cannot do that. What if I had variables in my denominator? So for example, what if I had 15 over 2x minus 18 over 2x? So the denominators are the same, even though I don't know exactly what the denominators are, because I don't know what my x exactly is, that's okay. So since the denominators are the same, I'm going to keep my denominator, and then I'm going to do 15 minus 8. Now if I think, or minus 18. If I think about 15 minus 18, I can't take away 18 from 15, right? 18 is greater than 15. So that tells me this is going to be a negative number. It is going to be a negative 3. If we think about using the number line, if I start at 0, 15 is above 0. If I'm subtracting 18, I'm going down below 0, because if I subtract 15, I'll get to 0. I'll be here at negative 3. If you want to use KFC, we keep our 15, flip our subtraction to addition, and change 18 to negative 18. So now we're adding a negative and a positive, which really means we're subtracting. However you want to think about it. But that will give us negative 3 over 2x. Again, I don't want to change this to a mixed number, because then I'm going to have my x in a weird spot, so I'm going to keep it improper. And remember to have my negative here. You can put your negative with your 3, or you could kind of have it in front of the fraction like this, or you could put it with the 2x. However you want to represent it, just knowing that this is going to be negative. So that is adding and subtracting with common denominators. You could see mixed numbers, you could see 3 fractions that you're adding or subtracting, so it won't just necessarily be 2 of them, but just think about we use the exact same strategy when there are more fractions. We just move from left to right. Okay, so lesson 5.2, that was good. So that was just common denominators. Then we worked on lesson 5.3, which was when the denominators are different. So if the denominators are different, for example, 6/8 plus 7/12, and I want to add these 2 fractions. I notice that their denominators are different, right? I have different denominators, so that means the piece sizes are different. So I need to find a common denominator. So a couple of different ways we can do this. We can use the ladder method to find the least common multiple of 8 and 12, because that's going to be their least common denominator. Or I can multiply 8 times 12. That's going to give me 96. You can always multiply the denominators, and that's always going to be a common denominator. Or you could list out the multiples of 8 and 12 and see what the first one that they're going to have in common is going to be. So either way you want to do it. To me, this is kind of the easiest. So 8 and 12 are going to have a 4 in common. 8 divided by 4 is 2. 12 divided by 4 is 3. So I'm left with a 2 and a 3. They don't have anything in common. So I know that this is going to be my LCM. So 4 times 2 times 3. 4 times 2 is 8. 8 times 3 is 24. So 24 will be my common denominator. So then I need to scale up both fractions to have a denominator of 24. So 6/8. If I think about how many 24ths that is, to get from 8 to 24, I multiply by 3. 6 times 3 will give me 18. So that's going to be 18 24ths plus, if I change 7/12 to have a denominator of 24, to get from 12 to 24, I multiply by 2. So I do the same in my numerator. 7 times 2 is 14. So now that I have a common denominator, I can add my numerators. 18 plus 14 is 32. Keep my denominator the same. I can write it improper or change it to mixed, but I do need to simplify. So I know that 4 is going to be a common factor of both. So that will give me 8 over 6. I still have a common factor of 2. So I need to keep dividing till I get to 4 over 3. I could also write 4 over 3 as 1 1/3. Either way is correct. So this is part 1. Tune in to part 2 if you want to see some more practice.